Hey there guys, Mr. Carlson here. So what the heck is a mole anyways? In chemistry, we see this term quite a bit and it's a pretty important concept, so we better talk about it. When we use this term mole, all we really mean is a certain amount of something, okay? A good example of this would be if I were to ask you for 1 dozen of something, you would know that that means that it is 12. Whether we're talking about eggs or maybe roses or I don't know what else, donuts, all of those things are common things that we would use a dozen for. But you know that this term dozen just means 12 individual things basically. Well, in chemistry, that's what a mole is. So when we say we have a mole of something, we just mean that we have a specific amount, okay? And so we use that specific amount to calculate things like the mass of a substance or how many like atoms or molecules that we have. Like again, for example, let's say that we were working with eggs, okay? And let's say that we wanted to figure out how many individual eggs, let's say we worked in an egg factory, I don't know, and we had something like 1,476 dozen eggs. Well, that's quite a few dozen, but let's say we wanted to figure out how many individual eggs that would be. If I were to ask you to figure that out, if I said I have 1,476 dozen eggs, how many individual eggs do I have? Well, I'm sure you could probably figure that out. You would know, well, if I know that I've got this many dozen, and I know that for every dozen there are 12, that's pretty simple to figure out. I would just have to multiply that, right? Because I know that there are 12 eggs for every 1 dozen eggs. And so 1,476 times 12 eggs, that would tell me how many individual eggs I have. And actually, let me punch that in the calculator. I'm kind of curious. 1,476 times 12. That means I would have 17,712 eggs. And so again, this process right here of me figuring out I've got this many dozen, how many individual eggs do I have, and I can just multiply them and get the correct answer. We're going to use the same process when we're working with the mole and determining amounts of different chemicals or different compounds. It's the same exact process, okay? Now I want to point out one more thing, and that's the way I set this problem up right here. This is sometimes called dimensional analysis or like unit conversions. But basically, the way that I set this up is to help me figure out whether I'm going to multiply or divide my number that I'm starting with right here. And the way that it helps me figure that out is the way I plug this part in right here. So we're starting with this measurement, 1,476 dozen is my unit of measurement essentially. And I want to convert from dozens to individual eggs. And so when I do that, this is my conversion factor. So right here, this is called a conversion factor, which is basically just an equality. Conversion factor is just how many of one thing for how many of another thing. And it's a way to convert from one thing to another thing. In this case, converting from dozens to individual eggs. The thing to remember is whenever I'm using a conversion factor like this, the unit that I want to convert into always needs to go on the top, like that. So in this case, I wanted to convert out of dozens into individual eggs. So I put eggs on the top. And if I look at the math, like when I do this, it would be 1,476 times 12 divided by 1 is how I would read that. This times this divided by 1 dozen. When I do that, what's going to end up happening is anytime I have these units if I have the same unit and I divide by them, what ends up happening is they cancel each other out. So when I go this times this divided by this, whenever I divide the same unit, it ends up canceling out, and it would leave me with the unit that I want, which in this case is eggs. So 1,476 times 12 divided by 1 would give me 17,712 eggs. Okay, so keeping all of that in mind, let's look at how we use that in chemistry then. So if I look at this, a mole, so 1 dozen is 12. Well, a mole is this many right here, which is a really big number. It's 602 sextillion, which is 602 billion times 1 trillion. It's a really big number, which kind of makes sense because we're talking about atoms and molecules, which are really, really, really small. And so we have a lot of them that make up different compounds and things like that. So when we say that we have a mole of something, this is the amount that we're talking about. It's this specific number. Now, the way that we write this, because we obviously don't want to write it like this every time we do a calculation, it's going to be written in scientific notation like this. So 6.02 times 10 to the 23rd. So that 23rd, remember, that's how many decimal places that I would have to move from here all the way to here. It's 23 decimal places. And so that's what a mole is, 6.02 times 10 to the 23rd. This is sometimes called Avogadro's number. Avogadro, whoops, can't spell. Avogadro's number is what it's sometimes called because it's named after Amadeo Avogadro, who did a lot of work in helping to figure this out, essentially. But nonetheless, let's see how we would actually use this. So if we look at this equation right here, 2H2 plus O2 to give 2H2O. So hydrogen and oxygen combining to make water. These numbers in the front here, which balance out the equation, they tell us how many moles of each substance that we've got. So like this equation right here is telling me that it takes 2 moles of H2 combined with 1 mole of O2 to make 2 moles of H2O. So when we learned how to balance equations, we talked about how this number tells us how many of the atoms or the molecules. It also tells us how many moles that we have of each thing. So let's say that I wanted to figure out, I've got 2 moles of hydrogen. How many individual atoms, it'd be molecules of hydrogen do I have? And so just like with the example with the eggs, all we have to do is, well, I know that for every 1 mole, there are 6.02 times 10 to the 23rd molecules. And so I could set it up just like that. Start with 2 moles. And I'm going to multiply it by my conversion factor. And so remember, the thing that we want to convert into needs to be on top. So in this case, I want to go from moles to individual molecules of H2, right? That means on the bottom it's going to be moles. And so my conversion factor is this right here. For every 1 mole, there is 6.02 times 10 to the 23rd molecules of H2. And so if I were to multiply that out, we get 1.204 times 10 to the 24th molecules of H2. And so that's how simple it is to convert from moles to individual atoms or individual molecules, depending on what we're talking about. We're just going to use this relationship right here, that there are this many individual particles for every 1 mole, and we can convert between the two. We could do the opposite. So let's say a problem asked, for example, let me go over here actually. So let's say a problem said that you have 7.3 7.32 times 10 to the 23rd atoms of gold, let's say, and you wanted to figure out how many moles that would be. Well, we would use the same equation right here, the same relationship, this right here, to convert between the two, and we would set it up just like this, except for this time, we want to convert from individual atoms into moles. So I'm going to go times, use my same relationship, but this time I want to convert from atoms to moles. So now moles has to be on top of that conversion factor, and on the bottom needs to be that individual atoms. So let me come back over here for a second. So remember right here we had molecules, individual molecules on the top, moles on the bottom. So remember that this would end up canceling out when we divide it. Well, this time I want atoms to be on the bottom so that it will cancel out when we do that. So I'm going to have that 6.02 times 10 to the 23rd on the bottom and 1 mole on the top. So now to do this, I would go 7.32 times 10 to the 23rd times 1, which would just be this again, so I really don't have to do that step, but 7.32 times 10 to the 23rd times 1 divided by 6.02 times 10 to the 23rd. And so let me do that real quick in my calculator and see what I get. 7.32 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. I get 1.22 moles of gold. So if we have this many atoms of gold, that means we have this many moles, 1.22 moles of gold. So that's the steps to convert between either to convert from moles to individual particles or to convert from individual particles to moles. It's just using this relationship right here to go between the two and then knowing when to have this on the top or it on the bottom, depending on what you're starting with and what you're going to.